frequency symbol is, or formula is, for one wave, what was the time? That formula will be on your data sheet. Remember we spoke about a data sheet previous class? Okay, so for one wave, what was the time? So here, for one wave, the time was 4 seconds. So that is 0.25. Now, what is the unit for frequency? Hertz. Okay, right, now just there at the bottom is a graph that you won't get a lot in this chapter. You'll get more position time graph, but just to show you the velocity, I spoke about how it's oscillating, and I said when it is here, the velocity is 0, it slows down, and then it goes faster, fastest, D, and then it goes up until G again. And then it goes faster until D here, D, and then it goes slow until A. Stop. Now, why do we have D in the negative and D in the positive? Anyone for a sweet? Yes, Khali? No, nothing about the distance. Distance or direction? Say again? Okay, then finish your sentence.
Velocity is traveling at the same speed as D.
Is in the same speed as D? That does not make sense.
So it's the speed.
No. Anyone else? The question is here, if you look at the pendulum, here, okay, it's going to A, D, G, D, A, D, G. Now, D here is positive and then it's negative, and then it's positive and then it's negative. And my question is, why? Yes.
It's moving from left to right, so it goes from right to left, crosses, starts over, and goes back to right.
Halfway there, not fully there. Yes, Chidi? This is Chidi, eh? Not? No, Claudie. Yes? Oh my word, guys, please. I'll get your name wrong lots. Yes? So you say here it's plus, here it's minus, here it's plus. No, that's wrong. You're all halfway there, but not fully there. If we say we choose to the right to be positive, then if it goes this way, it's going in the positive direction, so then the graph goes up. And if it's going to the left, it goes in the negative direction, then it goes down. It has to do with left and right, positive and negative, but you weren't fully there.
I was the closest.
Yeah, but not complete. All right. Now we're going to do a quick class activity. I want to do this quite fast, if we can. All right, so I need, let's take the two of you don't have dresses on. I want one to stand there, the tallest one, and one to stand on the table, please.
The shortest one.
Shortest one on the table.
On the table.
On the table. Right, did you say over to the class activity?
Yes.
Alright, now for the class activity, we're going to have a pendulum. Now let's say, how long must the pendulum be? What do they say there? How long must the pendulum be? Can you read? 1 meter. Okay. Now this is as close as 1 meter I'm going to get today. Okay, so we're going to put it up like this, 1 meter. So you're going to just close the windows, go. Right? And you're going to hook it on the thing that's probably not underneath there, so you can stay. Right, now they amplitude of the wave influence the frequency or the period of a wave. You can see there we're going to have a pendulum. The length there must be 1 meter. Ours is more or less 1 meter. And then we're going to take it up and we're going to drop it and it's going to swing. And now it says to an amplitude of 0.4 meters. Okay, so what you are going to do, just keep a reference point so he knows where's the starting position or the rest position. And you're going to take 0.4 meters. How many centimeters? Because this is in centimeters. Say again? 40 centimeters. So measure off 40 centimeters. It must be a straight line when you measure. Do you need help? Do you need assistance? You have it? No, you guys don't have it. Sure. So what he's going to do now is he's going to let it go and we're going to count for 10 oscillations. Now 10 oscillations will be, wait, it's going to start here. 1, 2, 3. Okay, we're going to take the time, not mine. Timer. There it goes. Good. I can take the time. Okay. No? This?
No, I can take
This is starting. I've got it. Stopping. 3. Stop. Stop. 3. 4. Okay, but don't lean because you want to. Okay. Right. Now, when you let it go, please check that it's not swinging to the side. No? Yeah? It must swing back and forth, otherwise it's going to go against the window and then the whole thing is. Alright, are you ready? Yes. Steady and go. Did you start? 2, 3, 4, 5, 6, 7, 8, 0.40 centimeters, right? Are you ready? 1, 2, go! 1, 2, 3, 4, 5, 6, 7, 8. Check. Nice. And who gets there? Stop. Okay, what's the time? Say again? 1875. Okay, now we're going to do this again, but now from an amplitude of 1 meter. Okay, so it's going to go all the way. Almost. Guys, ready, steady, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you stop? All right, sharp. Thank you, young man. Leave everything there because we're going to do another experiment. You can go back to your table. Yes, Kuma, what do you have? 1984. All right. So we did an experiment now. Now, in this experiment, we must have few control variables. we must have a independent variable and a dependent variable. Right? Okay, so we had the investigation question. We must actually have an hypothesis as well. What is an hypothesis? Yes?
Uncalculated guess.
An uncalculated guess. Now, a guess, I don't like that word guess, I like an uncalculated statement. Because a hypothesis must not have a question mark. And it must also not be a I think. You take yourself out of the equation. You must say, a question here is, how does the amplitude of a wave influence the frequency of the wave? A hypothesis will be, as the amplitude increases, the frequency increases. Okay, so it's a statement. It's not a question, it's a statement. Okay, now, in this hypothesis or in this question, we must have a controlled variable or variables. What do you think in our experiment will be the controlled variables? Oh, you have a long name. What's your name again? What's that? Pole. Okay, what is the controlled variables? Think about what you saw. Yes? Are you friends? She's calling you. Are you picking up? That is true. She is forcing you. Say again? Okay, answer. Say again? What distance? Yes. No. A control variable was something that we kept the same for both experiments. Okay, so the object, so our pendulum was the same weight. We didn't change the weight of the pendulum. So our control variables, Alright, so unfortunately, grade 10s, we didn't finish. But luckily I see you tomorrow for a double. Okay, so tomorrow we go with very hard and I'm pretty going to get a lot of homework tomorrow. Right. Who has my stopwatch? You. Yes.